Dun, dun, dun. Yep, there you go. It's recording now. With the quick introduction and house rules done, I'll hand you over to Lashani to kick off today's session. So Lashani, take it away.
Thank you, Anne. Let me share my screen. So hello again. I'm Lashani, from an engineer from the Forge platform team. And today we are excited to share some of the improvements that we have done with the Forge tunnel. And I'm thrilled to have Khan, our principal engineer, presenting advancing app code tunnel debugging with us today as well. Yeah, so let's go. The agenda for today is what is Forge Tunnel, the changes that we have implemented in the tunnel provider, Ngrok versus Cloudflare, and a little bit more about tunnel architecture and tunnel improvements with Cloudflare. And then I will do a very quick demo on a simple app with what I'm going to present next. And then I will hand it over to Khan to demonstrate advanced app code debugging and profiling. Okay, to start with, I believe everyone here today has a good understanding of what Forge is. So I'll begin with what Forge Tunnel is. Forge Tunnel via Forge CLI allows developers to test, debug their Forge apps locally without having to keep deploying the changes. So you can start a tunnel for any app that has been deployed and installed onto a site by simply running Forge Tunnel command. One note here that you should deploy and install your app first at least once before tunneling. How tunnel will help you? You can get real-time logging for your local app. By inserting console log statements in your code, you can see the output in the Forge CLI as the code executes. Another note that console logs only functions within the backend code logs, not within the front-end log codes. And also, tunnel helps fast turnaround for changes. The tunnel watches for the code changes and rebuild your app. And you don't need to deploy your app after every change, which lets you test fixes faster. There are some limitations around different types of app. We can discuss that later. Moving on. So what we have done before Forge CLI 10.1.0 version, Forge tunnel utilized Ngrok as the tunnel provider. However, due to various concerns around this implementation and the limitation that affected user experience, we made the decision to transition to Atlassian managed Cloudflare tunnel to replace the current existing Ngrok tunnel implementation, which is available from CLI version 10.1.0. As an example, with the Ngrok, it doesn't support anonymous users, so developers needed to set up Ngrok account and set credentials before using this tunnel, which is no longer a requirement with the Cloudflare. Okay, so with that, let's have an overall picture on how tunnel is working. So as an example, when a developer execute the Forge tunnel command via Forge CLI, what CLI would do, it will ask Atlassian Tunnel Manager, Atlassian Services to create a tunnel, and Atlassian Service will create Cloudflare tunnel and associated DNS records, cache it along with the app details, and will send these data back to CLI so that CLI will link to the Cloudflare tunnel with its local server. And also Forge CLI will bundle its local code and we'll start a local server, and the connection will be available. So let's look at the invocation flow. So when an invocation is triggered, request comes to Atlassian services, and it will check whether a tunnel is open or not. And if it is, it will try to invoke it via Cloudflare, and it's already linked to your local server, and the invocation will happen through your locally bundled code. So this is very high level picture of what is happening with the tunnel architecture. Yeah. So few improvements with this Cloudflare flow to highlight is no special setup is needed because Atlassian manage Cloudflare creation and everything, and you don't have to set up or create any special accounts, unlike with Ngrok. And with Cloudflare geo steering feature, we have noticed some performance improvements with the network overhead, because what does that mean is with Cloudflare multi-region support, traffic is directed to pools associated with the specific countries or regions. And unlike with the Ngrok, where we had to bound to only to US region due to some limitations that we had with the flow. So we have noticed like around 80% within 500 millisecond network overhead with Cloudflare, and around 50 with Ngrok flow. Okay, so with that, I will quickly show you what I have discussed so far with the simple app. So I have this simple app created. So this is a UI kit app. There will be a lot of different test cases with different limitations with the tunnel, but just simply point out what it could do. So Forge tunnel verbose. Forge tunnel verbose command will give you more insight on what will happen underneath the request. So as an example, you can see the tunnel provider is Cloudflare, and it is asking Atlassian services to create a tunnel, and it will pass you the tunnel details back. So that CLI would create the connection with the Cloudflare, and then it will bundle the code and will start listening, create a server and will start listening on this port. So as an example, I have this console log, and yes, this is a simple case. So in practically things could be complicated. So as you can see, if I change this code, it will rebundle the code and start listening again. So in this site, I have deployed the app, and you will see the changes should be coming over here. And another thing I mentioned earlier is for the front end, based on how it executed, these console logs won't be coming in the output here, one of the common questions that we are getting. And also manifest changes. These manifest changes will be picked up as part of the deployment. Hence, as an example, if you change anything here, it won't reflect in your tunnel execution. And we have done some improvement there as well to enhance error messages. As an example, if I change this one, it will tell you that changes has been detected, but you have to redeploy to pick these changes. But it won't interrupt the tunnel service. It will go on as it is. Yeah. rebundling and tunneling. So this is a very simple case, and the limitations and the other concerns regarding the tunnel is available in our DAC pages if you're interested. So this is pretty much it, what I had to demonstrate based on the Cloudflare changes. So I'll stop here for a while if you have any questions on this.
Any questions?
Yes, I have a question, Priya. Yeah, so we tried this latest CLI. I think it is enabled after 10.0.1 something. So we tried it out, but what happened? We are running inside the VPN, which is Zscaler. So when we run this, we don't see any error or logs, whether it is blocking by VPN or something. So any recommendation for it? How will know what are the URLs it is blocking? Because it doesn't show anything there.
Yeah, so one thing is you can check with your networking team whether anything with the Cloudflare tunnel, I can give you the link details, is getting blocked, because this was kind of a limitation with the Ngrok flow as well. If your firewall rules are blocked, it won't be able to connect to it. So you will have to enable it. And regarding the debugging, I would say try tunneling without VPN. And even if it's still not successful, please raise an support ticket with us so we can check with you detail on how to debug it by creating a separate tunnel and see whether what is the issue with the tunnel.
Okay, sure, that we can try it. It would be great if you can just share the links also in a chat, like what links so I can just tell directly to the VPN team to enable those links.
Yeah.
Thank you so much. Awesome.
Mm.
Yeah, thank you. Any other questions before we move on to Khan? 3, 2, 1. Okay, I think we can move on. If there are any other questions, if we still have time at the end, we're going to have a Q&A. Okay. Thanks, Lashani. Khan, handing over to you.
Yeah, thank you. Let me start to share the screen. Okay. Yeah. So Lashani already present recent improvement on how we move from Ngrok to Tunnel, and also like a lot of it's make it our developers setting up is easier, and also like got a better performance. So next, what I will do is I will present some new capability related in terms of like debugging, profiling that we have developed recently. Note that the new one is for NodeJS-runtime Forge. Yeah. The Cloudflare tunnel one is could be available for both Sandbox runtime and Node runtime. But what we demonstrate for the debugger and the profiling today is only for Node.js runtime for code. Okay. So let me. All right. So let me start with the. Let me trigger the app first. Yeah, so as you can see, basically on this app, there are two tests here. Welcome to Forge Devden and Hello World. So just now you notice that the second test is take a bit longer time to render. And later we go demonstrate. I will explain more on how we can profiling, or like how to explain that. So first, let me show you how we can do the Forge Drag debug. First, so we can run Forge tunnel app to see like what is the option for that command. So in this case, you can see that there are some options that you can notice that we can pass the debug to enable the debug mode, and we need to provide the debug function handlers. So this one is a must. We need to specify so that we know the program know what function handler we want to debug. and also the POC, because later we want to attach to the debugger and we need to know what is the POC. This one is optional, and the default one is 9229. Okay, so let me do the debug. Let me run the debug command. Yep. So in this case, I run the fork tunnel with debug option, and the function handler is in index handlers, so that that function handler is defined in the fork manifest that you can see here. Yeah, yep, this one. So next step, what we can do is we can attach to this debuggers. Basically, we just need to define a new configuration for VS Code. In this case, the type is node and the port. It needs to match with the port that you can see the output from the fork tunnel debug command. The port is 9229, so we just specify here. So once we define the configuration, then we can click attach the name here that you can see attach fork app debugger. So I put the names easy to recognize, and then we can click this. Yeah, let me see. So it say debug attach. So from now we can start to debug the program, and we can put some breakpoint. I already put the breakpoint. What next is we can trigger the fork job again. Then we can see that the program will now you see the debug is enabled, but it's not stopped. So normally I noticed the first time the bundle and also the debugger is not recognized. So it might take like from the second time. So we can trigger again, and as you can see, so this one is the one. This is one of the resolver definition, and as you can see, the program we log request. We also can see the request from the variable view on the left side, and you can see here. So basically, it's context payload. So all of the values show here. So it's very convenient. I think it's the same debug experience that we often do for standard node. Yeah. Then we can do a step-by-step debug like this. Yeah. Then we also can go inside the functions, right? Like I want to go to the function feeble recursive. Later I explain more on that, but yeah, let's demonstrate it's possible to do the debug. And you can see now in this case, X is 30. Yeah. Then we can go out of this one. Yeah. And yeah. Then what's next? Yeah, so I just demonstrate how we can do the debug the fork job code, and now we could do some profiling. So just let me stop. I can stop this attached debugger. So now there's no more attached debugger. So as you can see, they will say that the debug is ending. Let me trigger the page again. Yeah, and you can see the first one is on way faster. So let's look at the app code. Right? You see the app code. This is the two tests that just now displayed. So the first one is hello work, hello message, and the second one is data. Hello message is get from by calling the invoke get hello string, and the data is come from get test. Then let's look at the resolver function. You can see the get hello string is very simple, actually just return a string. But for get test is more complicated. In this case, I just do some simple calculation just now so that I demonstrate how we can debug the program. It also called a Fibonacci recursive using the recursive algorithm. So it's not it's not the implementation is not effective. Basically, there will be a lot of duplication in terms of calculation. Yeah, so it will be slow. And then I also purposely write some function that use a lot of memory for the demo purpose. Later, I could do some profiling for memory. But basically, what it does is that it will create an array with 10,000 elements, and each element is a string with length 100. Yeah, so this is the function like create a random string array, and every time we will generate a random string. But note that I create a new class called string handler here, just a grabber for string. Later for demo purpose that we can see it from the profiling easily. Yeah, so the string handlers it will keep the result in the random string here and then insert in the arrays. Okay, so that is the program how it works. So let's do the profiling. So in this case, what I could do is that I will attach it again. As you can see, there's a message say debug attach. Yeah, now I can refresh the page, and then the program will stop at this line. So I want to do some reprofiling on my program. So if you notice on the construct, there's a circle button here. It says take performance profile. If I click this, there are a few options: CPU profile, heap profile, and snapshot. In this case, I will select the CPU profiles. And then I will let it run on. There's a few options we can determine how long it's going to run. In this case, I want to run until the light return hello world. So I will pick a breakpoint and I choose until the hello world. Okay, yeah, right. That's on. And then let's look at the result. As you can see, immediately there's a new file generated from the profiling, and it's also shown on the tab here. So let's sort by total time. And you can see the Fibo recursive function is at the top. It takes like 200 milliseconds. So this is one of the bottleneck of the program. So yeah. So from this result, we can see how long each function. Another one, we also can see that generate random string is take total around like 7 milliseconds. Create random string take like 30 milliseconds. So it's quite fast. So only the Fibo recursive is not effective. So let's try to improve. Basically, I already prepared that. I think the solution is quite familiar to you. But we can do is we can implement is like a sequential program by remember the last two values. Yeah, and then we just calculate. Yeah, and loop and just updating here. Yeah, it's a sequential algorithm and it must be faster. So let me change the code and let me finish it. Let me finish the invocation and then I change Fibo sequentials. Yeah. Okay. Then let's every time we change the code, basically it will bundle again, but this one requires us to the tunnel is still there, but the this one already, I think I already did yeah, I think every time we change the code, we go run another process to run. The tunnel is still there, but we need to click the attach button here to attach the debugger again every time we change the code. Yeah. Then yep, let me refresh the page. Sometimes it's hit like middle of the process, or somehow I just need to hit again so that it stop at the first line. So I want to do the profiling from this line. Yeah, so I do the same CPU profiling, pick breakpoint, and until return hello world. Yeah, so let me see. So there's a new result, and yeah, and you can see, I expect there will be. Yeah, I could sort it. Yeah, so you can see now we no longer see like the recursive Fibo recursive there because I think it's very fast and it doesn't show in the CPU profiling. And there are other function like create random string array and random string is there. Yeah. Yeah, that's how we can use the VS Code to do the performance profiling for our Forge app code. So basically, it helps us to identify, for example, whether any hotspot in terms of our app code it like slow, and then we can come up with some idea how to improve or improve the performance. Yeah. Is there any question? So find the question that how we do the debugger and also do the CPU profiling. Okay, great. So I think I could move on with the next one first, and next, yeah. So next I will demonstrate another one is we can do the memory profiling. Let me do the reload trigger the app again. Yeah. Then we also do this time we will do the heap snapshot. Basically, we want to take the snapshot of the program after we call the create random string array. So because this function use a lot of memory, so we just want to demonstrate how we can use the debugger, fork tunnel debugger with VS Code and then get the heap snapshot. Yeah, so that you can see, let me sort by retain size. Yeah, so that you can see one at the top is the string handler. This is the class that define the program, the fork trap code, and its stack total is like 28 megabytes. So this is some hint for us to, based on that, we can identify where is the part of the code that we use a lot of memories. Yeah. I think it's helpful because when we run the fork lambdas, there are some limitation on the lambda. I think it's 500 megabyte or something. Yeah, so it will be in case of your fork trap invocation when it's run out by memory. So we can use this kind of thing to debug locally to see how is the memory footprints. Yeah. Yeah, that's on for my demo today. So you feel free to look at the VS Code tutorial. I think VS Code also explain a lot about how, because the way we do the fork tunnel debugger is like Node.js standard. So VS Code is support that, and you also can play more with all the options. There are like heap snapshot, and also like you can take the recording for the heap usage over time. Yeah. What else? We recently, actually just today, I think today we just published the document, so you can also check out our tutorials. We will make some announcement soon, I think today or tomorrow. You can there are some new tutorial about debug with EJ and VS Code. So basically, what I have demonstrated for debuggers is also possible to do in IntelliJ. Yeah, the profile performance code. Yeah. Yeah, that's sorry, I stopped sharing. So that's on for the demos. Need any question?
Khan, we do have a couple of questions. Oh, great demo, by the way.
Yeah.
We have this one from Andre. So in the Zoom chat, is it working similar with, does it work the same with workflow, post function, validator, and conditions? Yeah, if you can check the question in the
Yeah.
Zoom chat.
I'm not sure what does mean workflow post function. I'm not very familiar. I think I haven't heard
Yeah,
about
yeah.
that.
I could
But
explain this.
yeah.
Okay, so you replied yes. I mean, you've showed the perfect example with invocable functions, but there are a few other types of functions. Maybe I'm wrong, but custom fields or post functions or scheduled triggers works a bit different. Could we debug the same as well?
Yes, so any app code that we invoke via Lambda is going to be possible to do on via the debuggers. Like I have demo today. So it's web trigger. What else? I think async events. Yeah. But I think async event might be a bit hard to debug. I haven't tried yet. Maybe I can try. But web trigger is possible. Yeah.
Okay, thanks. I can see a thumbs up. So I think Khan answered the question. So there's another one from Ramesh. Ramesh, do you want to read your question?
Oh, so do you have any downloadable source code, right? What you executed right now,
I
right?
see.
Can we download some from public Bitbucket or somewhere? Can we test it out at our end? That's my question.
I see. I think these capabilities, there are no special. So you just run fork create, then you will get a sample fork trap. And then you can play around with what I have done. I think Ian just share the page. Then there's documentation there. Yeah, you can try out. If you have any question, feel free to drop some question on CDEC. Maybe I can help to answer. Yeah, if you try.
Okay.
Okay, thank you. we're way ahead of time, so we have more time for questions. Does anyone have any other questions, comments regarding today's session or in the demonstration, in the demos?
Nothing actually. It was a good session, good information and insights. Thank you so much for that.
Yep, thank you. So seems like we don't have any questions, so we're gonna end a bit early today. So just a reminder, we're gonna upload the video in the Atlassian YouTube channel. So I'm gonna post that page here. Okay. And then for next month's session, if anyone is interested with Rovo and building Rovo AI agents, we're gonna be discussing it sometime third week of August. So keep a lookout on the ACE Atlassian Developers chapter, and we'll be posting an update there. Okay. With that, thanks everyone. Have a nice day.
Thank you
Thank
all.
you.
Thank you.